Hey everybody, week 35, block day 1. We have a shortened day today, so we're going to try to get through this really fast. So, using the empirical rule of normal distributions to estimate the percent of data within a specific intervals of normal distribution. So remember, if it's a sigma, it's population. If it's S, it's a sample. And so this was the empirical rule, 68% between -1 and 1, 95% between -2 and 2, 99.7% between -3 and 3. Just a quick refresher from Monday's work. All right, so what percent of the data is greater than the mean? Okay, so we have to shade the corresponding region, and we have to state whether it's population or sample data, determine each percent, and explain your reasoning. Ooh, that's a lot. Let's go on. All right, so they want to know what's bigger than the mean. Okay, well, if we shade everything above this way, going this way, all the way this way, it's going to be 50% of the data because the mean is at half. So, and it's a sigma. So let's quickly type some things out. The sigma values indicate, values indicate that this distribution represents data from a population. The mean is a measure of center. 50% of the data is greater than the mean. Easy, let's go on. What percent of the data is between the mean and 2 standard deviations below the mean? So they want to, come on, let's draw. They want to go from here to here. So I know that this is going to be half of the 99%, 99.97%. Or wait, no. 95%. Sorry, I was misreading it. So half of 95%, so 95 divided by 2 would be 47.5%. And this is an S, so it's a sample population. So let's answer some questions. All right, so let's go. So for this, the S values indicate that this distribution represents data from a sample. Furthermore, since 95% is between -2 and 2 deviations, half that would be 47.5%. Let's fix that. Deviations, there we go. All right, well, let's go on. What percent of the data is between 1 and 2 standard deviations above the mean? All right, well, we're pretty much just, we have to figure out what would be 2 to 0. So from 2 to 0 would be 47%, remember? 0 to 2. So from 0 to 2, it's 47%. 47.5%. Okay, so from -1 to 1, that would be 68%, remember? 68%. So if it was if it's half of that, that'd be 34. So I'm going to have 34% here, and then between 0 and 2 is 47, so I'm going to subtract by 34%. So let me shade this in. This is going to be 13.5%. Jeez. Let's do some mental gymnastics right there. All right, and it's a sigma, so it's a, let's take a second right now. In 3, 2, 1. So I don't know if you're going to like this, but so the standard deviation is, I know that 47.5% of the data is within the mean and 2 standard deviations. I also know that 34% of the data is within the mean and 1 standard deviation. So subtracting those values, I know that there's 13.5% of the data is between 1 and 2 standard deviations above the mean. So basically we're just, taking this and we're trying our hardest to just do the mental math to be like, okay, what percent of the data will this be? So it says what percent of the data is more than 2 standard deviations below the mean. Okay, so starting here and going this way, all the way that way. Okay, so it's an S, so let's type this out. I know that the S values indicate that this distribution represents data from a sample. Furthermore, I understand that I know that 50% of the data is below the mean. I also know that 47.5% of the data is between the mean and 2 deviations below the mean. I wonder where we got that. Yeah, that was this one right here, B, 47.5. So if you take that data, 50% minus 47.25, 47.5, that would be 2.5% of the data is more than 2 standard deviations below the mean. There we go. All right, so we're going to go on to the next part in 5, 4, 3, 2, 1. Let's continue. So 2, consider each normal curve. State whether the distribution represents population data or sample data. Then determine each percent, shade the corresponding region under each normal curve, and explain your reasoning. What percent of adult males have a height between 62 inches and 74 inches? Well, before we read that, 1 sigma represents a data value that is 1 standard deviation greater than the population mean, or -1 and sigma represents a data value that is 1 deviation less than. All right. So looking at this, it looks like that, hey look, the sigma, so straight up, we understand, hey look, there's a sigma. So the sigma values indicate that this distribution represents values, data from a population. So sigma is population, the S is the sample. All right, well, let's go on. So between 62 inches and 74 inches. All right, well, I need to draw. Let's draw it then. So 74 and 62. Okay, so we're going to have to figure out, what's between, how much is between here and here, and how much is between here and here. Well, we can go back and we can figure this out. So let's hold up. Give us just a second in 3, 2, 1. All right, guys, so looking above at our work, between 1 and 2 standard deviations was 13.5. Between 1 and 1, so 1 and 1 was 68. So if we add those together, 71, 81, 81.5. So I guess we'll have to type this out. All right. So between 1 standard percent, let's just say 68% of the data is between 1 standard deviation above the mean and 1 standard deviation below the mean. I also know that between 1 standard deviation below and 2 standard deviations below, it is 15.5%. Therefore, between 2 standard deviations below and 1 standard deviation above, it would be 81.5% of the data. Yeah, there's a lot of typing on this. So what percent of the adult females are taller than 68.5? Okay, well, looking at sigma, so there's the population. Let's continue. So we know it's 1 and above. So we have to figure out what's 1 and above. Well, I know that this is 50% of the population. 50%. I know between here and here, 0 and 1, it's going to be 34%. So I have to subtract it, and I will get 16%. All right, let's do our little typing then. Lots of typing. The sigma values indicate data that this distribution represents data from a population. 50% of the population is above the mean. Also know that between the mean and 1 standard deviation is 34% of the population. Therefore, 50 minus 34 would equal 16% of the population. 16% of the data is above 1 standard deviation above the mean. There you go. Let's go on. What percent of the history test scores are between 63% and 70%? Well, let's draw it in. So 63 and 70%. Well, by golly, we just said, it's 34%. Let me shade it in. Okay, but let's talk about it. Okay, the S values indicate, because it's an S, see? The S values indicate that this is data, this distribution represents data from a sample. We know that between 1 standard deviation below and 1 standard deviation above, above would be 58% of the data. Half the data is represented from the mean to one standard deviation of the mean. And therefore, 34% of the population is between the mean and one standard deviation above the mean. The end. Alright guys, I hope this wasn't too much writing, but glad to see you back, and I hope to see you for block day 2.